Hey everyone, we're going to continue on with some more geometric proofs. So in the last video, we detailed using congruent triangles and proving that triangles are congruent using geometric proofs. Now we're going to go one step forward and use CPCTC to prove that parts of congruent triangles are congruent. So CPCTC, as we know, stands for corresponding parts of congruent triangles are congruent. As I briefly mentioned earlier, we're going to, after we've proven that the triangles are congruent, go a step forward and prove that parts of the congruent triangles are congruent. So before we go into a full proof, I want to go over some examples of when to use CPCTC and when to not use CPCTC. So I have a list of some givens and some things that we want to prove. And I want to go through and identify which ones we'll use CPCTC and which ones we won't. So we should be familiar with when we prove that triangles are congruent, we're going to be using postulates and theorems like side, 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 angle, hypotenuse, leg, postulates and theorems like those. So if I'm proving that triangles are congruent, I'm going to stop there. So here I won't use CPCTC. But for example, down here, I'm proving that parts, so these are parts of a triangle, and I'm proving that those parts are congruent. So whenever you see just parts that you're trying to prove, here is where we will be using CPCTC. So first, in this proof, if we go through and actually do it, we're going to have to first prove that the triangle is congruent to the other triangles. The triangles are congruent. Once we've put congruent, we can prove that the individual parts are as congruent as well. So it's kind of easy to identify. When you see the triangle symbol, you know you're not supposed to use CPCTC. When you see the parts of a triangle, that's when you use it. So down here, we're always going to be given some sort of information and then asked to prove something. So here we're being asked to prove that the triangles are congruent, so we know we're not up and use CPCTC. But this last one right here, we are proving parts are congruent. So we have to first prove that the triangles are congruent, and then we will use that congruent course of congruent triangles are congruent. And that will then tell us that these corresponding parts are also in fact congruent. So let's go through and actually fill out a proof. We're given some information. We're given that angle DCB is congruent to angle WCB, and that is already marked here in the diagram with these congruent markings in the angles. We're also given that angle W is congruent to angle D. So we know that these two are also congruent, and that's marked in the diagram as well. So in my statements, I'm going to write down my given that angle DCB is congruent to angle WCB, and that angle W is congruent to angle D. And my reason behind this is that it is what is given. So I'm moving towards proving that the triangles are congruent, so then I can prove that these individual parts are congruent. So I want to find something that I can use. Well, we've got a, here, segment BC is a shared side between the triangles, and that means that they're congruent. And we know this is because of the reflexive property. So I would write down that BC, segment BC is congruent to segment BC. It's congruent to itself. We know this as the reflexive property of congruence. Well, from here now, I have an angle, and a side, congruent to an angle, and a side in these two triangles. So I can prove that triangle DCB is congruent to triangle WCB. So these two triangles are congruent by angle, side. And so this should be familiar from the last topic, but now this new piece is that we're going to go a step further And now that I've proven that the triangles themselves are congruent, I can prove that angle WBC is congruent to angle DBC. And those angles, WBC is this one right here, congruent to DBC, angle DBC. So now I've proven that those two angles are congruent, and my reason for this is going to be CPCTC. And use that abbreviation so you don't have to write the full corresponding parts of congruent triangles are congruent. And that is our completed proof.